In this video, we will see RMS value. To get these notes, you can visit this website link electrical-engineering.app. Now, first of all, what is RMS value or what is RMS? So, simply RMS stands for root mean square. It is a mathematical method used to determine the effective value of a varying, usually periodic quantity such as voltage or current in AC circuit. Now here we can see this is a sinusoidal waveform. Let's say it is a voltage waveform. Now what will be the definition of RMS value? So RMS value is the equivalent DC value that would produce the same amount of heat or power in a resistor as the AC signal does over one complete cycle. Now why current are constant? So calculating power is straightforward. We know that in case of DC, what happens? Simply we can write power is equal to voltage into current, or we can write it here like directly. Power is equal to voltage into current simply. But this happens in case of DC. But in case of in AC circuit, voltage and current vary with time. Sinusoidally, usually. Now, to get the instantaneous power, it also varies. So the instantaneous power will also vary. To make comparison and perform calculation, we need a single constant value to represent these varying quantities. So RMS value, this RMS value provide that by giving us the DC equivalent power. Now we will understand how we can calculate this RMS value. Now here this is the sinusoidal waveform. Here this is the maximum value or peak value or amplitude of this waveform. Now from this value to this value it is called as peak to peak value. Now we need this maximum value. Now here on this side this will be positive 10 volt. Let's say we are assuming. Now on this side we are assuming minus 10 volt because this will be same, but here this will be positive and here this will be negative. This is also maximum value or peak value and this is also maximum value or peak value. Now we see that values like 230 volt or 120 volt, these are the RMS value of voltage. Remember that. Now here let's see RMS value. This RMS stands for root mean square. Now to calculate RMS value, we have to go in reverse direction. That is, we have to first calculate the square, then we have to take its mean, and then we have to take its root. So square, mean, root. First step is to calculate square, then mean, then root. Now here we know that generally the AC alternating current is a sine wave. So for that we are assuming this Vp is equal to 10 volt. So first we will take square. So let's take the square of this Vp. Now if we take the square of Vp, it will become 10 square is equal to 100 volt. And again, if we take the square of this minus 10 volt, then it will be positive 100 volt. Because if we multiply a negative number with a negative number, then that will be a positive number. So here we can see we get something like this, minus 10 square is equal to 100 volt. Now the resultant waveform will be like this, where this 100 volt represents the maximum value. Again this 100 volt represents the maximum value. Now second step is to calculate its mean. So its mean will be Vp square divided by 2. So simply to get the mean of this, we have to simply divide this by 2, because this is the waveform like this. So if we need to take the mean of this type of waveform, that time what we have to do, we have to simply divide this by 2. So it will be Vp square, that is 10 square divided by 2. That means 10 square is 100. 100 divided by 2 is 50. So the mean of this waveform will be 50. Now our third step is to calculate its root. Now if we calculate the root of under root of 50, it will be 7.07 volt. Now here we can write volts because this is our third step and final step for calculating RMS value. So its RMS value will be 7.07 for this Vp. Vp here we have taken 10 volt. So if the Vp or maximum value or peak value we know is 10 volt, that time its RMS value will be 7.07 volt. Now this was the example. Now if we want to get the formula for calculating RMS value, then from these steps we can get the formula. So first we have taken Vp, that is maximum value or peak value. Then we have taken its square. So we have considered this value, then we have taken its square. Then we have taken its mean. Simply we have divided by 2. Then finally we have taken its root. So it is root. So as we know that to calculate RMS value, we have to go in reverse order. That is, first we have to consider or first we have to find its square. Then we have to find its mean and then we have to find its root. So it is root mean square. Now finally we have taken the under root of this term Vp square divided by 2. So it will be under root of Vp square divided by 2. Now this square and this under root will get cancelled. So it will be Vp simply and this term will be under root of 2. Now this is our VRMS, that is root mean square value for voltage. So it is equal to Vp divided by under root 2. Now since we know that under root 2, 1 upon under root 2 is equal to 0.707. So finally we get the formula for RMS value or root mean square voltage is equal to 0.707 Vp, where this Vp represents maximum value or peak value and this VRMS represents root mean square value of voltage. So this is the final formula for this. Now next, what does RMS represents physically? Now if you apply 230 volt RMS to a resistive, let's understand this. Now if we apply, here we are taking the example, we can say, or let's make a star here. So if you apply 230 volt RMS, 230 volt RMS AC to a resistive heater, it will generate the same heat as applying 230 volt DC. So if we apply this to heater and if we apply this to heater, then same heat will generate. They will generate same heat. So remember that this 230 volt RMS value of AC is equal to 230 volt of DC. So that's why RMS voltage is the standard when you see AC voltage like your home supply. So if your wall outlet says 230 volt, that's 230 volt RMS and not peak. Remember that. Anywhere if you see this 230 or 120 volt, these are the RMS value of voltage. So don't forget to like, share and subscribe to this channel, and thanks for watching.